Alright, welcome to Tactic Academy, where we'll be looking at units and measurements. So in this topic, we'll look at different things such as prefixes, significant figures, unit conversation, and also everything like that. So without even wasting our time, let's get started. Alright, so the most important thing that we need to ask ourselves is we need to know what a unit is. Alright, so what is a unit, by the way? Anyone to say the answer? Anyone to say the answer? What's a unit? Alright, yes, Mavis. Okay, so we can say a unit is just a standard quantity used to express a physical quantity. Alright, so a unit is just a measurable, identity of a physical quantity. So we can say it's a standard quantity is a standard quantity used to express a physical quantity. All right. So it's just a standard quantity which can be used to express a physical quantity. All right. So it will be used to provide a common communication among scientists. All right. So it will be used to provide a common measurement and also just communication within scientists. So the moment is, if we know to say time will be always measured in seconds, so meaning that all the scientists will need to obey to that unit for time. All right. So it will aid in communication and also just in establishing the required or the standard measurement of a certain physical quantity. All right. So for example, let's talk of length. Length. All right. So this length, what's its unit? So the unit that will be found in length, we know is meters, right? All right. So the other thing that we can talk of is, let's say, temperature. So temperature, the standard or the only known units for temperature as to be standard is kelvins, right? So sometimes it can be Celsius, which will be measured in degrees, but the standard one, there is a standard of which I won't say right now. All right. So we can also talk about, let's say, mass. All right. So we can talk of mass as well. So also mass is measured in kg. So that's its unit. So meaning that if we have these things, then those are units. So a meter, second, Celsius, Kelvin, those are units. All right. So they will be aiding in communication among scientists. All right. So that is about a unit. So it's just the identity of a physical quantity. So when you see a unit for this, we'll be able to say this is a physical quantity that was used here. All right. So then the other thing that we need to ask ourselves is, what is a measurement? So a measurement, when we are saying a measurement, this is just a process of assigning a numerical value to a physical quantity using the same units that we are from talking about. So we can say we can say a measurement is a process. So it's a process process of assigning a numerical value to a physical quantity. All right, using units. All right, so that's what we'll be using. Okay, so we'll be using that to express, or we'll be using units to assign a measurement or to give a numerical value to a physical quantity that we are trying to determine its value, or whatever dimension you are taking. All right, so these measurements can be direct. So a measurement can be direct or indirect. A direct measurement is a situation whereby you are given, let's say, can you measure the distance of, the distance of this, let's say a distance of this plot length. All right, so you'll be able to find, let's say, the distance of or just the length of a house. So you measure that length in meters, right? So those meters now is just direct, like you are just taking it just immediately. You are getting the units in terms of meters, just direct. But in a situation, so you are measuring the distance in that case. All right, let's say the distance will be measured in meters. Can you measure the distance from here to there? You measure straight. All right, so that's what we call now direct, e.g. meters, measuring what, the length of a house. All right, that's a distance. You're measuring a distance. Then what about just indirect? In indirect situation, it's a situation whereby, let's say, you are told to calculate a distance. In that case, the only data that you have been given, you have not been given a tape, a measuring ruler, something like that. You only have, let's say, a speed. You also have time. All right, meaning that you calculate, we know to say speed is equal to distance over time taken. All right, so meaning that for us to find distance, we'll say distance is equal to speed times time. All right, like that. So meaning that our distance will be measured indirectly. So we need to have the data for speed, we need to have the data for time. So that's what we call indirect measurement. All right, so not really important, but we just have to understand, even if we are studying, we need to know measurement, because we need to understand. We can't stay away from understanding these things. Okay, so there are basically 7 basic fundamental quantities, okay, of which those ones, they are just basic, and we'll be using everything to get things from there. So they were considered basic, and their units were mastered, or were determined to say they will be everywhere. All right, and that was happening when scientists had to sit down and also talk about what are we going to do with the issue of us misunderstanding the units that we are giving to people. Everyone would like this book in different units. This one will write temperature in Celsius, this one will write temperature in Kelvins. All right, so now the scientists had to sit and come up with the standard physical or fundamental physical quantities. So those fundamental physical were assigned fixed units. All right, so among those they are 7 in number. So there are 7 fundamental quantities, so we can list them. So we give its length and also everything like that, the unit. So we'll have the first thing that we can talk of is length. All right. The second thing that we can talk of is mass. All right. The third thing that we can talk of is time itself. All right. So the third thing that we can talk of is we can talk of electric current. All right. Electric current. All right. So the other thing that we can talk of is temperature, right? Temperature. What else? All right. So temperature. Then we can also talk of what's this in chemist? Amount of a substance. That's a mole, right? So we can say it's called just a amount of a substance. That's a fundamental quantity. We call it amount of a substance. All right. Okay. So that's it. Then the other thing that we can talk of is the luminous intensity. That's some kind of right, luminous. All right. So now we'll be now giving the units or just the units. So for length, we use anything related to length that should be measured in meters. For mass is always kg. That's the standard. That's the scientist came about. Then for time is always second. We take a small letter s. Then for electric current, that's something like you know current. So meaning that current is measured by let's just give to say current will be always measured in amperes, and amperes will be presented by capital letter A like that. All right. So for temperature, the standard is Kelvin. All right. Then for amount of a substance, this is more, right? This is more. Then the units now, your unit should be just more. You remove the E at the end like that. Okay. Then for luminous intensity, that's candela. All right. Candela will be measured in will be abbreviated. Its unit will be CD like that. All right, in small letters. So that's about these things. So the scientists had to what? To sit down and also come up with a standard SI units. So these are the units we are talking about. So when you hear the word SI units, this simply means standard the international unit. So S stands for standard. So that's the standard we'll be using now. Okay, that's why we call it SI unit. So standard international the unit. All right. So they are standard worldly, they are accepted everywhere. So when you go to UK, you say, what's time? Oh, time, let's say it's a whatever, but it should be given in seconds. That's it. All right. So those are the 7 basic fundamental quantities. So they were measured and also accepted worldly. They are units. So pay attention to that. I'm sure you learned those things. All right. So now the other thing that we need to know as we are studying physics, physics pH 110, those stuffs pH 100, everything like that. So for prefix, we need to know some positive ones and also negative ones. All right. So here I'll put the negative ones. All right. Here I'll put the positive ones. Okay. So for negatives, I'll start with the let me start for negatives. So for negatives, you need to start like that. So there will be let me write a table. Write a table. All right. So these will be enough for negatives. All right. Okay. Then for positives, so we'll start for positives. So we have a factor and also a prefix itself and also its factor. All right. And we'll see how these things will be used. They are very important, so make sure that we master them. So you can come up with any mnemonics. They are very bulk a bit, and they will be used in your test, in one of the tests. They will be used on that one. You just have to follow. It's inevitable. All right. Okay. So here, this column will have the prefix itself. All right. Then the symbol and also the factor. All right. So even this side will have the prefix itself, the symbol and the factor. All right. So this line is for like that. Okay. So here for negatives, we'll start with the, we'll write a prefix here. Okay. Prefix here, then symbol. All right. Factor there. Okay. Then also here we'll have a prefix there. Symbol there, then a factor there as well. All right. So a factor will be there. Then we can start with the negatives ones. So the negative ones, we can start with the des. Okay. So the prefix is called a des. All right. Okay. So it's called a des, like that. All right. So we have des there. So this des, it has the symbol d. All right. It's just a small letter d. Then what is its factor? So the factor that we are going to find here is 10 to the power negative 1. All right. So the other thing that we can talk of is cent. So when you hear of centimeter, cent, something like that, just know that they were removed from the symbol is c. That's why we find centimeter, you get. So the factor that should be there is c negative 2, like that. All right. So the other thing that we can talk of is miri. Okay, so miri will be presented by small letter m, and the factor is 10 to the power negative 3. All right. So after this, we can also have what we call micro. All right. So this will be presented by a letter mu, like that. All right. So this one will have the factor of 10 to the power negative 6, like that. Then the other thing we can talk of under negatives is what we call now a nano. All right. So this nano will be presented by the letter small letter n. Then what will be its factor? Its factor will be negative 9, like that. All right. Then we can also add what we call pico. All right. So this pico will be presented by by small letter p. Then the factor will be negative 12, like that. Okay. So there's this one, the last one. There are a lot, but these are just the most important one. Is called femto. So we'll present by small letter f. Then the factor will be negative 15, like that. So you can make a mnemonic. You make a mnemonic No one should make a mnemonic for you, but yourself you should make a mnemonics, and you see how we'll be using them. Let's be fast. All right, make sure you copy it down. All right, so for positive ones, we can start with the deca. All right, it's called deca. Okay, so this deca will have the symbol D as well. All right, so this D will carry the factor of just 10. You know, decade, it came from decade, the period of 10, you see. So then the other thing that we can talk of is, if from here we can also talk of hectare. All right, something like hectare. All right, so this hectare, it will be presented by H. All right, then that will be 10 to the power 2, like that. So that's a hectare. All right, then we'll add also what we call kilo. All right, so kilo will be presented by capital letter K. This should be capital letter K. All right, then the factor will be 10 to the power 3, like that. Okay, then the other thing for positive ones, we can talk of mega. Is called mega. So it will be presented by the M as capital letter, like that. Please don't forget this. Then it will have the factor of 10 to the power 6. All right, so the other positive thing we can talk of is what we call now giga. All right, so this giga will be presented by the symbol G. Then it will carry the factor of what? 10 to the power 9. All right, so after that we can also add the last one for just positive. We may have other ones, but these are just important ones. All right, so it's called Taylor. So presented by the capital letter T, then it will have the factor 10 to the power 12, like that. All right, so these are the prefix that we need to know. All right, so we need to master these. All right, okay, so we need to master these. So master these, copy them down, and they'll be used where we are going there. Okay, so for example, let's say we are told, for example, okay, example, so example, express the following in terms of prefix. So this is how questions will be coming. All right, PH 110, pay attention. So this is how questions will be coming. So if I like to say, let's have an example here. So we can give an example to say, okay, so we can have an example. Let's say we are given 0.000851 liters. Okay, so in short, we want to get this number. Try to have what is the first number as non-zero. Then from there, then the other goal that we should make is to at least bring the point to the nearest prefix that we know. All right, to the nearest prefix that we know as possible as we can. So what I'll do is I'll move this point there. All right, so I'll move it 1, 2, 3, 4. All right, I don't have any 4 with me if you check on the table list of prefixes. So 4, 5, I also have 5. 5 I don't have as well, so I'll go on 6. So I was moving to the negative, so I'll say this is 851 times 10 to the power negative 6, like that. Then it has, you get the point. So this now, this negative 6, 10 to the power negative 6, it has something in common. All right, so 10 to the power negative 6 is what we call micro. So it will be presented by the letter mu like that. All right. So that's what we'll do. So we are going to replace now is 851. All right. Then where there is just is 10 to the power negative 6, so we'll put mu. All right. Then it. Okay, so our goal is this. Now we are done. So we have expressed in terms of nearest prefix. So you begin with, say, 3 marks just for this. Okay, so let me give you another example. All right, so we try to be fast. So make sure you're writing this down. All right, so let's say again we are given this one to say 5, right? All right, let's say we're given 5.44 times 10 to the power negative 11 grams, like that. So what do we do with this one? So we don't have 11 in our table, so we'll move 1 point so that we can have, we don't have 10 as well, whereby we can take the point to this side, but we can only take a point to this side so that we get to have what? Negative 12 there, because it increased by 1. We're going to the positive one, so we are moving from negative, so the negative will increase. So now we'll say this is 4.4 times 10 to the power now negative 12, like that, grams. So we know negative 12 grams, go back. So negative 12 grams is what? I mean just negative 12 as a factor. That's the pico. You get the point? So that's a pico. All right. So we'll say 4.4. Then where there's the 10 to the, we'll just replace, substitution. You put picogram. You get the point? So that's how we express in what? In in terms of possible prefix. All right. So that is it. So the other one that we can talk of is let me give you another example. Let me say 73000. All right. Okay, 000. All right. So the point is here when you see just a number with like this. So I'll move this point to the nearest prefix that I note. So 1, 2, 3, 4, 5, 6. Do I have positive 6? Yes, I have positive 6, something like that. So let's go to that. So I'll say it's 73 times 10 to the power 6, like that. All right. So 10 to the power 6, like that, is what? 10 to the power 6. That's mega. All right. So that's mega. So we'll go to mega. So that will be 73. We'll replace where there's 10 to the power that factor. So we'll put mega like that. Okay. So then we are done. So in terms of prefix, so that's the 73 mega. All right. So the other one that we can give, let me give you another example. We can put let's say, let me give you 9 point, let me write 9.50 like that. All right. Okay. So then e to the power, let's say to the power 10 to the power negative 3, like that. Okay. No, let me just see. Let me not write that power. Okay. Let me just write like that. So that is it. So I'll move this point to say 1, 2, 3. All right. So that will be 9450 times 10 to the power 3, like that. Okay. That's a negative. I'm moving from negative. So that will be now 945. Then that factor 10 to the power negative 3, we know it. That is what? milli. Okay, so those who can see, that is milli. All right, where is it from the negative? So that is it. So that's milli. All right, so we'll say milli like that. Okay. Okay, sometimes you just, it's more like it's a substitution thing. All right, it's a substitution thing. Okay, so that is it. So sometimes we can say, we can be given to say, um mm, let's say convert the following into given units or prefix. Okay, so what we are going to do is, let me give you an example. Let's say I give you to say 20 204.0 kg. All right, then change it to what, to milligram, like that. So we use what we call chain formula or chain substitution. So what we do is, you bring the same number to say 204 like that, 0.0 kg. All right, so your duty is to cancel the unit, so you multiply. All right, so you multiply the relationship. Okay, you are intending to have what, milligrams, right? So what you do is, these kgs, you get the relationship for with the grams. All right, because you have gram, you're targeted to have a gram, and also to do something with meters, millimeters. All right, so what you do is, you write 1 kg down there. Okay, so you write 1 kg down there. So once you write 1 kg, then on top there write the relationship. So the relationship is what, is 1000 grams, like that. Okay, so this and this will cancel, then you have managed to get gram. So now how do you get a milligram? All right, so for a milligram, it's already there, right? I mean, we don't have it, so we'll find the relationship for a milligram. All right, so the relationship for a milligram, we said, is a milli, right? Let's go back to our table. So let's go back to our table. Milli, where is milli? Milli is 10 to the power negative negative 3. All right, so since it's 10 to the power negative 3 for a milli, so our target is now to change for a milli. Okay, so we are going to say a milli should be on top. So say 1 milli, it has the value of what, a milli has the value of 10 to the power negative 3, like that. You get the point? All right, so that is it. So you have now on top your gram and also your milli on top. That's the trick here. So we are going to say 204 like that, 0.0. All right, the kg have gone already, so times, we have 1000 there, grams, times. All right, so when a number is over like that, let's say x to the power negative or 2, when it goes up there, it will have what, x the power negative 2. So now it has already a negative, so that will be just a positive when this one goes up there. So that will be what, milli times the same factor, which is now positive 3. All right, so this will be 204.0 times, so that will be just 1000 times 1000, right? So meaning that this is 204.0, then times 10 to the power. So 10 to the power 6 is what, I mean, you bring those units that you what's this one and this one, so you say grams, oh, milligram, I'm sorry. So these are milligrams. Now you are done. All right, okay, so you have now left it in milligram. Okay, so we can give another example. Let me give another example on how we can convert units using this chain rule. Sometimes you can just do a substitution one. So let's say I give you to say can you write this one into the required unit? So I give you to say 25.9 liters, change it to what? To kiloliters. All right. So what you do is you write the same 2.5, no, 25 point 25 point what 25.9 like that liters. So you multiply now, you get, so we want to bring it kilos. Okay, so we are the liter is just okay where it is because it will be used in kiloliters. Okay, so we just bring the issue of kilo and they are substituting this one. So what we are going to do is we write 1 kilo like that, or right, 1k. It has the value of what from our table? That's C 10 to the power 3 like that. Okay, are we good there? Then meaning that this will be 25.9, all right, liter times kilo, all right, times the same one. Once it goes up there, then to be 10 to the power negative 3 like that. Okay, so when you multiply that one, it will give you what? It will give you what, guys? So it will give you 2.59 times 10 to the power negative 2, because the point will move once because there are zeros, they are variable. So that is it. Otherwise, that's how you express it. Now this is now kiloliters. All right, if we were to say kiloliters, or just KL. All right, so that's one way you can change the formula. So what if I give you this one? I give you this one. All right, okay, so they will be asking you different things, so you just have to know what is supposed to be. Otherwise, there are a lot of things to be asked. So long as you get the concept, you won't get lost. Okay, you won't get lost. You won't get lost. Okay, so let's say, can you change this one to the required unit? Let's say I give you 60. All right, 60 kilometer per hour to meters per second. All right, so what we are going to do is want to change now, use the same thing, chain rule. Okay, so we'll say 60 there. Okay, kilometer is on top like that. Pretend to say the hour is down there. So how do we change? Let me start with the kilometer to meters, by the way. So the kilometer will match with meters, then the hour will match with seconds. So that's what we do. The second is down, so you change down, so your second should be down, make sure. Okay, so your second should be down. Okay, then we know that 1 kilometer is equal to how many meters? 1 kilometer, who can give us the answer? 1 kilometer is equal to what? 1000 meters. So 1 kilometer is equal to 1000 meters. So what we are going to do, they go now, I'll start with the kilometer. The kilometer is up there, so I'll say 1 kilometer. All right, I'm sorry, 1 kilometer like that is equal to what? 1000 meters. All right, then I'm done with this. I'm done because I've substituted the value. Okay, then for hours, I'll say, what is this hour? So I'll say 1 hour because it's what I want is to cancel like that. Okay, the goal is to cancel, so you put them opposite, the other one up, the other one down. So what is the relationship in 2 seconds? So the second will be 36, okay, seconds like that. So you multiply now with a calculator. So you have, so once you multiply like that, you're going to find something 16.667 meters per second like that. All right, so we are done. So that is it. That's how you'll be what you'll be you'll be changing things using chain formula. Sometimes you can just substitute. All right, sure, you can just substitute. So like let's say I give you the same 60 kilometer per second. All right, so you pretend to say 60 kilometer is up, per is now second down. So what you do is this one is what, see, 60 times a kilometer in 2 meters, that's 1000 meters, right, over, so meters. Then for here, that was hour, by the way. So in 2 hours, that's how many seconds? So you put it, see, 6000 seconds, like that. So this is now meter per second. Then you'll be able to divide what is supposed to be divided. Then you find your answer to be 16.667, like that, meters per second. All right, so that is it. That's how we'll be finding these simple calculations. Okay, so we can dive now into what we call now prefix. All right, I mean significant figures. All right, okay. Okay, so significant figures. So this is now the basic trick that I'll give you. So from today you should know that so for positive ones, or there are only two scenarios. Okay, there are only two scenarios for significant figures. Okay, so the first scenario is the for non-decimal numbers, so a number that doesn't contain a decimal number. So in this case, where you don't have a decimal number, let's say you have 20634 or just 70000, there is no point at all. So those numbers are the one we call non-decimal numbers. There is no decimal in it. So how do we, what is the rule for that? So the best rule that we can say is all the first non-zero to last non-zero are significant figures. Okay, so I'll say all the first non-zero are all the first non-zero to last non-zero are significant. All right, something that is significant is something that is important in that measurement, or in that just dimension, or in just given numerical value. All right, so let's say now I give you to say how many significant figure does this one have? So say 17006. All right, how many significant figures are there? So we are saying all the, so the issue here is all the first non-zeros, all right, to the last non-zero. So since there is first non-zero, that's a number, and to the last, so all these are significant figures. So we can say 1 2 3 4 5. So it has 5 significant figures. All right, so 5 numbers are important. All right, so what if I give you this? I like to say, let's say 1300700. How many significant figures are there? So we are saying all the first non-zero to the last non-zeros. So so long as there is a first non-zero, right, then that's a significant figure. In short, every zero that embedded between the number is a significant figure. Then a number away before the non-zero is not a significant figure. So what we can say is all these are significant figures to here. All right, so count 1 2 3 4 5. So it has what? 5 significant figures. All right, Okay, so what if now we have 4, all right, 4 again, 4 0 0 0 or 0 like that. So this one will have all the first non-zero and the last non-zero. So these are the numbers. So here we are going to have to say it as 3 because it's 1 2 3. So 3 significant figures. All right, so the other example that I can give you, let me give you to say 0 0 5. All right, 0 0 3 2 like that. Okay, so how many significant figures are there? So we are saying all the first non-zeros here to the last non-zero, so those are significant figures. In this case we have 5 significant figures. All right, what other example can I give? Let me give you this one. So I like to say 0 0 0 0. All right, 8 3 1 0 0. Okay, how many significant figures are there? So we'll say 1 2 3 4 5 6 7 8 9. No, we don't count. These are not non-zeros. Okay, the last one is here, so we'll count from there. All right, so these are 1 2 3 4 5 6. So it has what? 6 significant figures. Okay, it has 6. Okay, so let me give you the last one. Let me say 9 4 0 1 0 3 0. How many significant figures are there? So we say this one is not a significant figure, it's non-zero. So all the zeros that are embedded between numbers are significant figures. So we say 1 2 3 4 5 6. So this has what? 6 significant figures. All right, so those are the what? Those are the one for non-zero significant figures. Okay, so that's case 1. What about case 2? So case 2, now we'll say case 2, we are going to say all the first non-zero. All right, so long as it's a first non-zero for numbers with decimal decimal numbers. So remember, the first case had no decimal points. Okay, decimal numbers. So the trick that we'll be using for decimal numbers is the trick that we'll be using for decimal numbers now will be, all right, so that we'll say all the first non-zeros. Okay, so so long as the decimal is involved, all the first non-zeros are significant figures. Let's say for example, I give you to say 2.00 like that. All right, so how many significant figures that has that one have? All the first non-zeros, they'll be considered to be significant figures. All right, all the first. So long as the number is supported, a point is there are zeros after a point, those zeros will be considered as significant figures. All right, so for this case we can have now 2 1 1 like that. So that's 3. So this has what? 3 significant figures. All right, so that is it. So let me give you another example. Let's say we have 5 0 0 3.12 like that. So how do we count the significant figures? So in this case you consider everything here. These are significant figures. So say 1 2 3 4 5 6. So this one has these 6 significant figures. All right, so the other example that we can give is let me like to say 0 0 0.0. All right, so long as the zeros are being supported by the point, like the zeros are after the point, those zeros are considered to be significant figures. So in this case you count everything, so that will give you what? 6. So these are what? 6 significant figures. So now in a situation now where you can't get confused now, get it clear now. If I write to say 0 point or just 0, let me write like this: 0, again 0, 5, 0 again, let's say 3, 1, 2, like that. How many significant figures are there? So you only start with a point, okay? You start where there's a number. You can't start from 0, right? So unless if there was a number here, these zeros would have been considered if there was a number this side. So in this case, we just start from here: 1, 2, 3, 4, 5. So this has what? 5 significant figures. All right. So that is it. The last one that I can give you is, let me give you to say 0 point, no, just 0, 12.001, like that. How many significant figures are there? So you count. This 0 is not considered, all right, because it has just started. So a 0 that will be considered is after a point, and on your left there are numbers there, okay? So we can say this will be 1, 2, okay, 3, 4, 5, like that. So this has 5 significant. So for positive ones, you only consider the zeros that are between numbers. Let's say A and B are numbers, all right? Then for this one, you consider significant figures for zeros that are what? For zeros that, so these zeros that will be found for non-decimal places, those are significant figures. But in this case, you only consider when a number is there, a point, then those zeros are there, all right? Those are significant figures, so long as it is not starting with a number. So a number is the one which will embed everything, okay? So if I give you, say, 9.00, all right, so all these are significant figures, all right? So that will be 4 significant figures, okay? So that is it, guys. That is it about significant figures. We have talked about significant figures, everything like that, changing kilometers, you know, converting units, what is a unit. We have talked all those things. So the other thing that we can talk of is the in the next part, we'll look at different questions. We'll solve a tutorial sheet, in short. So now, thank you very much for having time watching our video. Please subscribe and also share to your friends so that they can also get helped from these videos. They are very important, so make sure that a question will come, 1 or 2 questions will come, and that will push your marks. So don't hesitate to watch and also finish. Make sure that you note down everything in the video, because it will be of help. See you in the next video. So when you want to reach us, you can just you can just contact us on the number 09700200920, like that, okay? So that's Alpha. All right, so thank you and wishing you all the best. All right, bye.